Hello, once again, phenomenal ladies and gentlemen. It's Matifaru here, and welcome back to my space. Yes, this is the second video, the second half of the video on the shenanigans of limits involving infinity. And in the first part of the video, we've seen solutions and some explanations involving limits at infinity. So the first answer, we got these to be equal to infinity. The second one, we got these to be equal to infinity. The next one is this equal to infinity. Surprise, surprise, this is not infinity. It was the last question we did in the last video, and this is 3/8. Now in this video, we're going to look at the last two questions, number 5 and number 6, which are very similar to question number 4, but just a little tweak here and there. And let's see why they are different. So I'm going to start with number 6 for personal reasons. And the reason being that number 5 is actually the control. You remember I said at the beginning of the first video that there was a controversial chatter, and number 5 is actually the question, and you will see how surprisingly simple it is. So let's start with number 6. So we want to find the limit of 4x plus the square root of 16x squared minus 3x as x approaches negative infinity. So if we want to do this using the same tricks as we have seen in the last video, it's basically going to be the same thing. And let's do that again. So we have this to be equal to the limit as x goes to negative infinity of 4x plus square root of 16x squared minus 3x times, well, first and foremost, if we wanted to check why we needed to do anything superficial, let's see what happens if we actually try to make some direct substitution. So if we substitute negative infinity, then it means this gives us 4 times negative infinity. Like I said, we have to be very careful here. Infinity or negative infinity is not a number, but in quotes we have something like this that makes sense, in the way that we are multiplying 4 by a very, very large negatively large number, or should we say negatively very small number. Anyway, then we also have plus square root of, so in this case you have 16 times negative infinity squared in quote minus 3 times negative infinity. So because you are squaring a negative number, I'm saying again in quote, negative infinity is not a number, but when you think of it, so as you are approaching negative infinity, you have a very negatively big number. So when you square it, you get a positively big number. And when you multiply negative 3 by that same negatively big number, you also get, so this is going to be positively big plus another positively big, which is going to be very positively big. Here you are going to have negatively big. So you have negative infinity plus infinity, which is an indeterminate. So this calls for thinking of a special method to use, which is why we are going to rationalize. So we rationalize by the conjugate of this guy. So we have 4x minus square root of 16x squared minus 3x over 4x minus the square root of 16x squared minus 3x. Now, as usual, the difference of two squares we have 16x squared minus 16x squared minus 3x over 4x minus the same trick. Well, since this is a new video, let me do the trick again. So we factor out x squared from this. So we have 16. So let's factor it out. So x squared into brackets 16 minus 3 over x. So when you factor out x squared from 16x squared minus 3x, you're left with 16 and 3 over x. So because x squared times 3 over x will still give us 3x. All right. And we remember that square root of ab is equal to square root of a times square root of b. I've said this in a previous video, but like I said, it's a new video entirely, so we have to, show some old tricks again. So we have 16x squared minus 16x squared plus 3x all over 4x minus the square root of x squared times the square root of 16 minus 3 over x. The idea of making use of this trick of factoring out the variable with the highest power is just in order for us to land with things that look like this. So we know that the limit as x goes to 0 of a number over any power of x, any positive power of x to be precise, is equal to 0. Sorry, to infinity is equal to 0. And I like I stated in the warning in the first video, this is not equal to 3 over infinity. So we are just saying as x is blowing up, as x is going to a very large number, 3 over infinity will be going to 0. That is the simply solution, simple answer to that question. So it is not 3 over infinity. So I try to advise people not to write this as 3 over infinity before writing 0. Just write 0. So we know that 3 over x, as x is going to infinity, as x is getting bigger and bigger, will be going to 0. Okay, good. So this is equal to the limit as x goes to negative infinity. 16x squared will cancel out 16x squared, and we'll be left with 3x over 4x minus, here is where it gets interesting, square root of x squared is not just x. Square root of x squared is equal to the absolute value of x. I said this in the last video. So we have this absolute value of x times the square root of 16 minus 3 over x. Now, this is where it becomes interesting because it's different from the previous question. This time around, as x is approaching negative infinity, absolute value of x, so we know that as x is approaching negative infinity, x is negative. So there is no positive number in the neighborhood of negative infinity. So all the numbers in the neighborhood that are very close to negative infinity are negative. So it means that absolute value of x has to be equal to negative x, because we remember that the definition of absolute value of x is it is going to be x if x is greater than or equal to 0. That is, if x is positive or 0, we don't do anything to it. But if x is originally negative, we multiply it by negative 1. So that is negative x, and that's why we have this. So how does that influence what we're going to do? So this is going to be the limit as x goes to infinity, negative infinity, of 3x over 4x minus negative x times square root of 16 minus 3 over x. So this is the limit as x goes to negative infinity of 3x over 4x plus x square root of 16 minus 3 over x. Now we can factor out the x in the denominator to have 3x over x into bracket 4 plus square root of 16 minus 3 over x. So the x cancels this x, and that will give us the limit as x goes to negative infinity of 3 all over 4 plus square root of 16 minus 3 over x. And yes, we have surmounted all mountains that have come our way. So the limit of 3 is just 3. The limit of 4 is just 4. And the limit of 16 minus 3 over x, as x goes to infinity, because this is the square root of, so that will be 16 minus 0. Like I said here, the limit of 3 over x as x blows up is 0. And that is equal to, unsurprisingly, 4 plus 4, which is again equals to 3 over 8. Now, we've seen that this is 3 over 8 and this is also 3 over 8, which makes sense because oh no, not this, equals to 3 over 8. Yeah, now this is the one that makes sense, because as we are going to positive infinity where there's a negative sign here, we have this, and when there's a negative sign we also have the same thing. And number 5, drum roll. Okay, so the controversial one. As controversial as it might sound, it is actually the simplest one of the of the bunch, because this is, we know that the limit of f of x plus g of x as x goes to a is equal to the limit of f of x plus the limit of g of x. The limit of a sum is the sum of the limits. So in this case, we can simply say this is equal to the limit of 4x as x goes to infinity plus the limit of the square root of 16x squared minus 3x as x goes to infinity. And this is no longer news for us, because we already know that limit of 4x as x goes to infinity is infinity. We've also seen number 3, I think so, number 3, and this is equal to infinity. We showed it in the previous video. If you've not seen it, you can go back and check. Now this is equal to infinity, and this is no problem. We are fine with adding up infinity. So unlike the number 4 question where it has a negative sign, there is no problem. We can just add this up and this is done. We're done. Infinity. Now, in an exam scenario or in a test situation where you have not done this before, so it is something that you can quickly do on the side. So you say this is equal to this. So if this is A and this is B, you say consider B, which is the limit as x goes to infinity of square root of 16x squared minus 3x. Then you do what we did in number 3 all over again and make this equal to infinity. That is one way to look at it. So another way to look at it is to just use the usual trick of factoring out the highest value. So in other words, I want to do for this now. So okay, let me rewrite it. The limit as x goes to infinity of 4x plus square root of 16x squared minus 3x. So we can factor out by saying, okay, this is the limit of, as x goes to infinity, of 4x plus the absolute value of x. Everybody now knows the trick, 16 minus 3 over x. And since we are going to infinity, we know that absolute value of x is equal to x. So this is the limit of x goes to infinity of 4x plus x times the square root of 16 minus 3 over x. And with that, we can draw out the x. So x into bracket 4 plus the square root of 16 minus 3 over x. And this becomes the limit as x goes to infinity of x times times the limit as x goes to infinity of 4 plus square root of 16 minus 3 over x. The one on the left is just infinity. The one on the right, limit of 4 is 4, plus the square root of limit of 16 is 16. Limit of 3 over x as x goes to infinity is 0. So this is infinity times 4 plus 4, which is infinity times 8. Wow, that's a design. So a sleeping 8 times a standing 8. Sleeping will always beat standing. So this is equal to infinity. So yet again, we have gotten infinity. So mind you that this is infinity. We cannot use the same method that we have used to solve the question when it was negative sign, because we would end up in a place where we do not like. So what do I mean? So if we say the limit as x goes to infinity of 4x plus square root of 16x squared minus 3x, and I decide to multiply by conjugate. So we only think of multiplying by conjugate in cases where we have, in the main expression, infinity minus infinity. But let's see what will go wrong here if we decide to conjugate this. So we're going to have times 4x minus square root of 16x squared minus 3x over 4x minus square root of 16x squared minus 3x. And this is going to be equal to this. And we'll have again 16x squared minus 16x squared minus 3x all over 4x minus this, as usual, absolute value of x, the square root of 16 minus 3 over x. Then because we are going to infinity, we know that the absolute value of x is x. And this is going to give us the limit as x goes to infinity of 3x over 4x minus x square root of 16. We have done this over and over again in this video. And this is equal to the limit as x goes to infinity of 3 over 4 minus square root of 16 minus 3 over x. This is problem. Because why is it a problem? Because we get 3 over 4 minus 4. The square root of 16 minus 3x as x goes to infinity is square root of 4. This is equal to 3 over... You can see that the limit is no more there because we have dropped the limit. Because we have found the limit of this guy. The limit of 3 is just 3. The limit of 4 is 4. The limit of this guy here is 4. This is 3 over 0. This is not the limit of something as the denominator is going to 0. This is saying we want to divide 3 by 0. it is not equal to infinity. Not in this case, not in any case. 3 over 0 is not, I'm emphatically saying it, it is not equal to infinity. We can have the limit as x goes to 0 of 1 over x squared to be equal to infinity. Limit as x goes to 0 from the right of 3 over x to be equal to infinity. That doesn't mean that 3 over 0 is infinity. That means that as x is going to 0 from the right, you're going to get positive infinity. It doesn't mean you should do 3 over 0 is equal to infinity. So again, the limit as x approaches 0 from the left of 3 over x is going to be negative infinity. So which means as x is becoming closer and closer, this is the number line, this is 0. As we are approaching 0 from the right, so this is 0 plus, and as we are approaching 0 from the left, this is 0 minus. So if I put in a very small number minus 0.00001, I'm going to get a negative big number, which is, and as we keep getting closer to 0, it's going to, blow up to either positive infinity or negative infinity, respectively from the right or the left. Okay, so 3 over 0 is not equal to infinity. And emphatically, we cannot say square root of 16 minus 3x is the same thing as plus or minus square root of 16 over 16 minus 3x, where we get 3 over 8. So this method is a no for when the question has positive sign, and some questions are just simple by default. If you already know that this is going to be infinity and this is going to be infinity, the limit is infinity plus infinity, which is equal to infinity, and in that case it's as simple as that, and there is nothing wrong with the question being simple. Okay, and if you don't want to go direct, the next best thing is to factor out the x as this. Since it is not infinity minus infinity, you are allowed to do that, and going with that method, you get infinity times something, which eventually gives us infinity. So I hope with that you are able to maneuver questions that has to do with radicals and infinity at the same time. In my next video in this playlist, I'm going to look at a question that involves some trigonometric shenanigans at infinity as well. So if there are parts of these two videos that you still find confusing, that you need more clarity on, do not hesitate to drop them in the comments and we can discuss about that. Until we see you in the next video, keep pushing your limits, keep testing your limits, because that is the only way you can reach greatness. Bye for now. See you another time.